In today's review of factoring, we're going to look at factoring with a leading coefficient that is not 1. So something like now where we have ax squared plus bx plus c equals 0, where a does not equal 1. Okay? So this is a little bit different process. But in order to understand this process best, I think it's awesome to work it backwards. Let's see how these polynomials come into being, and then we can think about taking them apart. So the way these come in is we get two binomials that are multiplied, where we have a coefficient on at least one of the variables. So say I have 3x minus 2 and 4x plus 1. All right? Let's say those are my two binomials, and I'm going to multiply them to create a polynomial. Well, what we're going to do is we FOIL. With 3x times a 4x gives me 12x squared. The outside, the 3x times 1 gives me a plus 3x. The inside, the negative 2 times 4x gives me a minus 8x. And the last, the negative 2 times 1 gives me a minus 2. Then we combine like terms, and I get 12x squared minus 5x minus 2. That's our polynomial. If I want to work it backwards, start with this and work backwards to that, we have to figure out our magic numbers. And I want you to watch really carefully what's going to happen here, because you're going to see something kind of neat. I still get my magic numbers. I need two numbers that multiply to give me a certain total, and two numbers that add to give me a certain total. Now the add total is still the same as it was before. It's still this middle term. So it's going to add to give me negative 5. The multiply total, instead of just being this number that's out here on its own, is now going to be the product of these two numbers. And if you think back, it actually was the product of those two numbers when we did it before. It's just that the number up in front here, instead of being a 12, was a 1. So 1 times anything was just that number. So it really was always the product of that number. And that's why we call this the AC method, because we're taking A times C for our product, and B is our sum. So A times C would be 12 times negative 2, or negative 30. Now what two numbers multiply negative 30, negative 24? How about learning to multiply? That would help. Thank you. Sorry, getting ahead of myself. What two numbers multiply to give me a negative 24 and add to give me a negative 5? Well, again, we start thinking about products or factors of 24. That's 1 times 24. It's got to be negative. The sum has to be negative, but that's not going to give me a 5, so I'm okay. I have 2 times 12, but I'm not going to get a 5 out of that. I have 3 times 8. Oh, 8 and 3 has a difference of 5. So if the 8 is the negative one, and the 3 is the positive one, those are my magic numbers. Now, this doesn't factor into just x minus 8x plus 3, the way that our factoring did yesterday. What it does is it tells me how I need to split up my middle term. I have to take this middle term of negative 5x and re-express that as negative 8x plus 3x. So I split it up, and then we get a minus 2. But I want you to notice something. When I did FOIL, what did my middle outside-inside terms give me? They gave me a plus 3x and a minus 8x, didn't they? So the split up that I do here comes from the way we put it together in the first place when I had the factors at the beginning. So it's really figuring out what that split for the outside-inside is. What are the coefficients for the outside-inside part of our FOIL? That's where these two magic numbers come in. They give me that split on that B term, or that middle term. How do I split that up? Once it's split up, factoring is fairly straightforward. We group and group. Now the sign here in the middle is important. This middle sign does not go in either set of parentheses. So if this middle sign was a minus, we do have to wind up changing the sign that's right here. Since it's a plus, we don't have to change anything. But if it's a minus, we do have to change it. And the reason is because if we group after the minus sign, we change that, and we would change, well, I'll give you an example with that in a second, okay? So we'll talk through that in a second. So we grouped it. We take the greatest common factor out here. That's 4x, leaving me 3x minus 2. The plus sign that's here comes down. And then, I'm sorry, the greatest factor here. Well, 3x minus 2 doesn't have a greatest factor other than 1, so we'll just use 1. 3x minus 2. And you'll note now the 3x minus 2's are common, leaving me a 4x plus 1. And sure enough, when I factored it, I wind up right where I started before I started my FOIL problem. So it works out beautifully. So that is how we factor something with a leading coefficient that isn't 1. Let's practice that a little bit more. Let's say I have, I'll go 5x squared, and these are not so quick to make up, so I got to think a little bit. I'm going to go a minus 4 down here at the end, and we'll do a plus 8x in the middle. Okay? Let's do that. Let's factor that polynomial. So, we're going to do our AC method. I need something times something equals, and the same two numbers added equal. I got to find those magic numbers. The sum is going to be positive 8. The product is going to be 5 times negative 4, or negative 20. Okay, A times C gives me this number, and B gives me the sum number. Okay? So what two numbers multiply give me negative 20 and add to give me 8? Well, 20. The products of 20 are 20 and 1, or the fractors of 20 are 20 and 1. That's not give me an 8. How about 10 and 2? Well, 10 plus 2 is 12, but oh, it's negative 20. So one of these has to be negative. How about 10 times negative 2 and 10 plus negative 2? That would work. So 10 and negative 2 are my magic numbers. What are we going to do with that plus 10 and negative 2? We're going to split this middle term. The plus 8x is going to split into a plus 10x minus 2x. All right? That's how we use the magic numbers. We then have to bring down our first term. The 5x squared remains unchanged, and the minus 4 remains unchanged. Once we've got all four terms, now we group. Grouping the first two is easy. Grouping the second two, this time I'm grouping after a negative sign. So what was negative 2x just became a positive 2x inside the parentheses. I'm factoring out a negative 1, which means I have to change this sign also. So if I group after a negative sign, the rule to remember is I have to change the sign on the inside as well. The math behind it is because I'm factoring a negative 1 out of that binomial. You don't need to understand the math. All you need to understand is if I group after a minus sign, I have to change the sign on the inside. Once that's done, I now do greatest common factor on each individual. Here it's 5x, and I'm left with x plus 2, minus, greatest common factor here is a 2, and I'm left with an x plus 2. Now at this point, if the two things in the parentheses don't match exactly, you've made a mistake. You need to go backwards and try again. You did something wrong, you dropped a negative sign, you did something. They have to be a perfect match. If they are, we factor them out, and we're left with 5x minus 2. Now, let's finish this off and let's set this equal to 0. Now that we've got it factored, how do we use those factors to solve the equation? The way we use the factors to solve the equation is again the same thing we talked about before, the zero product property. That means either x plus 2 equals 0, so that means x equals negative 2, or 5x minus 2 equals 0. That's a little trickier. I have to add 2 to each side. So 5x equals 2, and divide by 5, so x equals 2/5. So I get my two solutions. Why do I have two solutions? Because the exponent on the equation here is a 2. An x to the second power equation will have two solutions. An x to the first power only has 1. An x to the third power will have 3. Now, as a little shortcut on this solving process, whenever I have ax plus b equals 0, I could shortcut this. The formula here is that x always equals the opposite of b over a. So if b is a negative, so if I have 3x minus 7 equals 0, then x has to equal the opposite of 7, negative 7, which would be positive 7, over 3. That's my solution. So there's a shortcut formula there if you care to remember it. If you don't, the algebra is pretty simple. Let's do another. 2x squared plus 12 minus 11x. Okay? 2x squared minus 11x plus 12 equals 0. That's what I want to solve. So, blank plus, or let's do the times on top. It really doesn't matter if you do the plus or the times on top. The product has to be a times c, which would be 2 times 12, which is positive 24. The sum has to be negative 11. So I need two numbers that multiply to give me positive 24 and add to give me negative 11. Well, if they're multiplying to give me a positive and adding to give me a negative, both numbers must be negative. So negative times a negative is a positive, and a negative plus a negative is a negative. Rules from that. What are my magic numbers here? I think we got negative 8 and negative 3 in the mix. So those are my magic numbers. What am I going to do with those magic numbers? I'm going to split my middle of my polynomial. So that's minus 8x minus 3x. The 2x squared still comes down, and the plus 12 still comes down. Now what do? We group. Uh-oh, I grouped after a minus sign. What was negative 3x just became a positive. I have to change this sign on the inside from a plus to a minus, because I grouped after a minus sign. Remember, if I group after a plus sign, if this is a plus sign right there, I don't change anything. It's only when it's a minus sign I group after I do that. So you factor out the 2x, and I'm left with x minus 4. And factor out here the greatest common factor is a 3, and x minus 4. The insides match perfectly. We're still equal to 0 here, by the way, all along. So x minus, I'm sorry, I should write the x before I start writing the minus sign. So x minus 4 is a common factor, and we're left with a 2x minus 3 equals 0. So x equals 4, because 4 minus 4 is 0. Or x equals the opposite of this, opposite of negative 3, which is positive 3 over 2. Because if I put 3 halves in for x, yeah, I don't get a 0 here on this side, but I do get a 0 over here if I plug 3 halves in for x. 2 times 3 halves is 3. 3 minus 3 is 0. Okay? One more. And again, you can watch this, or you could, if you think you got it, you don't have to watch this whole podcast. This is just for the sake of review. But let's create one more. 6x squared, and we're going to do a minus 5 down here. And then how about plus 13x in the middle? Okay, let's try that. So my product has to be a times c, or negative 30. My sum has to be 13. And again, the negative 30 comes from the 6 times negative 5, a times c, and this is b. So the numbers that do that, product of negative 30, that could be negative 30 times 1 or 30 times negative 1. Either way, that's not going to give me a 13. How about a 15 and a 2? Oh, I can get a 13 from that if the 2 is a negative 1. So negative 2 and 15. Now here's a little hint just for ease. If you have a positive and negative, put the negative one first. It's going to make the factoring portion a little bit easier if you put the negative one first. So we split that middle term into negative 2x plus 13x, or 15x. Sorry. Helps if you write down the right number. Yeah, if I wrote down the wrong number, it would show up pretty quickly that I have a mistake. 6x squared comes straight down. The negative 5 comes down. Now, why was it easier to put the negative 1 first if I have a negative and a positive? Because then I'm grouping after a plus sign, and I don't have to worry about changing signs. Greatest common factor here is 2x, leaving me a 3x minus 2. Greatest common factor here is a 5, leaving me a 3x minus 2. I'm sorry, 3x minus 1. Must be getting tired today, so I'm starting to make some mistakes. But I caught it because they knew they had to match, and since they didn't match, it's like, oh, yeah, 2x divided by 2x is 1. Wake up. So the 3x minus 1 times 2x plus 5. And I forgot to set it equal to 0 at the beginning, but that's okay. We can add that in. Now that we're completely factored, how do we solve that? Again, x is going to equal the opposite of 1, so positive 1 over 3, or x equals the opposite of 5, negative 5 over 2. Those are my solutions. So that's our process for factoring polynomials where we have a leading coefficient that is not a 1. And that's factoring. All right, watch it as you need. Hopefully this is going to help both with your geometry and your preparation for Algebra 2.